Hello guys, and welcome back to another video. Today we're going to take a look on the Polish notations of expressions. So let's get started. So we're going to be starting off by writing down an expression. Sorry for my mixed notations, but I'm pretty used to the computer notations. So right now we're going to have to translate it into a way you can input it into a computer program so you can evaluate it. So that's going to be a plus b here, then divided, then e at power c times d. We don't need a parentheses here because that's the order of precedence. And let's add here a plus f. Okay, and let's add it to the right side too. Okay, so now what we're going to need to do is translate this whole expression into a tree. So the way we do this is we look at the last executed operation. So in this case, it's going to be the addition of f. And now if you don't know what a tree is basically you have this node with a value inside, and each node has children, and the tree starts with a root node, it has more children, and that has children on its own, and then the tree continues, just like a genealogical tree. So the way we start, you get the last operation that's executed, and you put that as a root node. So you put the plus down, put it as a node, and then the left child of this operation is going to be the whole expression on the left. So basically all that is going to be in the left as a value when you're going to add the f. And that expression, you just take the tree for that expression to the plus. So when you start is going to put that division, because that's the last executed operation, which has a left child of that addition of a and b. So you put that plus, and you put a as the left child and b as the right child. The right child of this division is going to be basically the multiplication. Okay, we're going to have that tree for the expression in the second pair of parentheses, which has the last executed operation, a multiplication, and then on the left side it has that power of e and c. And then the right side of the multiplication is going to be the d. Okay, and on the right side of that plus, we're going to have the f. So now, when you look at it, you basically start with a root node that's going to have as a value always the nodes that have children are going to be operators, and the leaf nodes, the ones that don't have children, the end nodes, are going to be always operands. So you start by putting down as a root node the last executed operation, then you put the whole tree for that expression on the left side and the f on the right side. So you put that f on the right side, and here we're going to start by doing that. So the last operation that's executed in the left side expression is going to be the division. So you put that down, and on the left side you have the a and b, and on the right side you have the tree for that expression. So you put here the a plus b expression with the operator and its children, and on the right side you're going to have that multiplication, the power, and those values. So the way you write it back into that notation, which is called infix, is by looking at the tree and then getting from the root node and look on its left child, and then if it's an operator, again look on the left side of it, and then again on its left side, then on its left side, and just go there on the most left. Then you write that operator in between the operands. Then you write down the right operator. Then you put the division. Now we're going to put that into brackets because of the order of precedence. Then on the right side, you're going to have the whole expression, which has a left side of that e at power c, which is an expression on its own. And then we put the operator for that expression. That's going to be the multiplication. Now we're on that level. So we're going to put that multiplication down. Now once we have the left side of it, put it. And then now we're going to put its right side. And then you're going to go back up and add that plus, because we finished with the left child of all this. We're going to put the plus, and then on the right side, we're going to put the f. So it's right side. So this is called an infix notation. You might notice we have a pair of parentheses that is not there compared to the initial expression. Now that is because it doesn't matter if we put or not the parentheses, because it's going to have the same value, the overall expression, because that is how the order of precedence works. You have firstly the power, then have multiplication and division, and then have addition and subtraction. Now the next type of notation is going to be postfix in the Polish notations. So what it means, you have firstly the operands and then the operators is a postfix, a suffix to our word. So you put down the operands first and then the operators. So you go on the left side, you put then the first left child, then the right child, and then you put the operator. Now we finished with the left side of that expression. So now let's put the right side of that division, which is going to be another expression. So you go on its right, so you want to put the right child for the division, and what you put the multiplication expression. So that has a left child of that e, then the c, then the power, and that's the left side of the multiplication, and then you put its right side, the d, then the multiplication itself, then we finish with the right side too, so we're going to put the division. Then we're going to put the f, and then the plus. So this is a postfix notation. Now the next kind of notation that you might notice is prefix. Now firstly, if you see down an expression like this, so the root node is going to be the operation, and then its operands. So that's going to be the tree, and in postfix you put firstly the operands A and B, and then you put the plus. So prefix would be the same thing as postfix, but the operation is before the operand, so it's going to be before everything. So you start by going down and put the root node. So now that we have the operation, then it puts its left child, which is again an operation, which has its left child. That's going to be that addition, which has its left child, the A, and its right child, the B. Now I finish with the left child of the division. Let's put its right child, and we're going to have the right child as going to be the multiplication, which has a left child of a power, which has a left child of that E, which has its right child C, and now we finish with the power, so we're going to put the right child of the multiplication, D. And now we finish with the right child of the division, so we finish with the division, and we're going to put the right child of the addition, which is going to be F. So these are the ways you can convert the expression to its Polish forms. So basically postfix and prefix are the ones you are talking about when you're talking about the Polish forms, but infix is as well one. So the way you evaluate this is, let's do this on an example. So we have this 5 plus 7 times 8 divided by 3. So this is an infix expression. So let's convert that to a tree. So we get and see which is the last executed operation. And that operation is going to be the division because it's on the most right. So if they have the same order of precedence, you get the rightmost operation. So that's going to be the div. Then you put its left child, which is going to be the whole expression to the left, which includes 5 plus 7 and times 8. And the last executed operation is going to be the multiplication. So we're going to put the right child because that's a single element. And the left child will have the last executed operation, a multiplication, which has its right child there, the 8. And the left child is going to be that plus 5 and 7. Okay, and now we need to put this as a postfix. Okay, so to evaluate the postfix, okay, we're going to firstly write it down as a postfix. Go put the operands and then the operator. Okay, and to evaluate it, you basically have to group the two elements and its operator. They have to be the nearmost operators. You can't group the times with a plus or something. You can't group them. So you firstly get the two nearest elements. So you have to have a group of element to element operator. And then you evaluate that. So that's going to be 12. And now you're going to evaluate that with the next group that it has formed now. So once you evaluate this, you have the 12, 8, and multiplication sign as a group of two elements and an operator. So if you put these two operands, so now this is going to be the new expression once you've done the first part of the 5, 7, and plus. So what we basically do is group these two, but I'm not rewriting the whole expression. Now, for the sake of the explanation, I'm going to write that down. So this is going to be 96. And now let's write down again the whole expression. So let's write down now. We group these two to finish the expression. So if you rewrite down the expression, the postfix expression, with the new replaced value, you're going to have 96, and then you're going to have 3 and divided. Now this is a whole group, as you can see over here, and this is going to be 32. So you do the same thing to prefix once you convert the infix expression to a prefix expression. So let's take down an example. So what we do is put down an expression. So let's think of something. So you put down the 1, 3 plus 13 plus 8 divided by 3, and let's make that 3 at power 0 plus 1. So this is going to be our infix expression. Okay? So we're going to look at the last executed operation and put it down. So we're going to do this without the tree and its whole left side. Now we're going to have the last executed operation, the division, which has its left side of that plus 13 and 8. And its right side of the division, now we finish with the left side of the division, is going to have that 3 at power 0. Now we have that 1, the right side of that plus. So to evaluate it, you firstly find the groups that are formed between two elements and an operator. So two operands and an operator. And because it's prefix, it's going to be operator, operand, operand. And we're going to find those groups which are exactly like this, and firstly evaluate them. So this is going to be basically kind of the first level. Because you can see here, these are the one infix element, and then you just start grouping these into larger and larger expressions, and that's how you get the actual big expression written down. Okay, and then you put that 1 and the big plus. So this is going to be the whole expression converted without actually making the tree. It's basically the same thing, but you don't draw the tree, you just do it. So you group the elements that are operand, operator, operand, operand, and you evaluate their value. Then you get these groups now with a new expression, and that's going to be, and now you make this group, that's going to be 22. So this is how you actually evaluate Polish forms expressions. Okay, so let's talk about how we can evaluate these in a computer. So let's write down a prefix expression. So let's start with a prefix expression and how you can evaluate it in a computer with an algorithm. Now, we're not going to implement this into code. You should already know how to do that, but we might do that in the next video. So we write this expression down. And the way to start is we're going to need a stack. So if you don't know what a stack is, basically just like a stack of books. So what you have is just like your stack of books, you can only put another book on the top. You can't put it on the bottom or in the middle. So let's assume you have this stack of books. Okay? And the thing is, you can only put a new book on the top of the stack, and you can only take a book out from the top of the stack. You can't put it in the middle, you can't take it out from the middle. You can't do that without taking the books above it first down. So we're going to use this data structure. So you can have this in a computer as well, and evaluate our expression from right to left in a prefix. So you get a stack in which you can hold the elements. So you're going to have an element stack. And in this stack, you're just going to hold values, integers, the values of the evaluated expression. So you start from right to left and put into the stack. Now, onto a stack, the operations that you can perform on a stack are called push. When you put an element onto the stack, it's called a push. When you put an element in the stack, and when you get an element out, it's called a pop. Now, there are other data structures as well, but we're going to focus on the stack because this is what we need. So you start from right to left. So you get the first element, the 1, and you put it into the stack. Then you get to the second element, a 2. Then you get to the third character into our expression, okay, which is going to be an operator. Okay, so we got the first two elements. You push the elements in the stack. When you get an operator, you pop both elements. Okay, so now you get to the next element, and you push it into the stack. Then the 8, you push it into the stack. Then you get to another operator, and you pop both elements from the back, and you push in their result. And then you get to the last operator. Now, the stack at this moment actually looks 1 and 24 without the popped element. So this is how the stack looks, and then you pop these two elements and you push in their result. And this is the actual result of our equation. So you apply the exact same thing to a prefix. So you get 8, 3 plus to a postfix. So you go 8, 3 plus, then you go 11 minus 1 and multiplication. You should do the exact same thing, but instead of starting from right to left, you go from left to right. So you get the first element you put into the stack, the second element, and so on and so forth. So yeah, guys, thank you for watching. If you enjoyed this video, drop a like. And if you want to see more, click that subscribe button. So see you next time on HowToIT.